Okay, now I'm going to show you how the two basic parent functions, the exponential function and the natural log function, are inverses of each other. Graphically, you can see that they're inverses of each other. If you were to fold each of those graphs over that dashed diagonal line at a 45-degree angle, you'd be able to see that the log graph, the natural log graph, would fold right on over to the exponential graph or vice versa. But let's see algebraically what happens. So if we start with y is equal to e to the x, we're going to swap the x's and the y's. Well, in order to get the y by itself, remember when you have e for a base, the only way to get rid of the e is to take the natural log of both sides, which is, I'm sure, what I did right there. And then remember the laws of exponents. When the base value, when the value has an exponent, to expand it, you bring that value in front, and then you have natural log of x is equal to y times the natural log of e. And if you were to type natural log of e into your calculator, you get 1. So that cancels, and now you have y is equal to the natural log of x. And that is the inverse of e to the x. So algebraically and graphically, you can see that they're inverses. And the reason that's important for you to understand so significantly that these are inverses, when you start solving logarithmic and exponential equations, you're going to use the fact that they are inverses to solve those equations. You'll do inverse operations. And so if you get to a place where you can go no longer in exponential, well, you'll take the log of both sides, because log is an inverse to an exponential. All right, that's it for inverse of exponential and logarithmic.